Hello, this is Basic Chemistry, 4th edition, and this is Structures and Solids of Liquids, Chapter 10, and we're in the last section today, Changes of State. So when you boil water, it's still water. When you freeze water, it's still water. So solid water is water, and liquid water and gas water is all water. So when you change state, all you're doing is supplying it with enough energy to, in the case of solids going to liquids, we call that melting. A solid is very orderly, arranged in a matrix where all of the atoms are very regular, kind of like crayons in a crayon box. And then you give them enough energy and they randomly kind of move across each other. In the liquid state, if you absorb more energy, you will change it from liquid to gas. So it takes temperature, it takes heat to raise the temperature, say, from -5 to -4, but then it takes more energy to melt it. So even though that the temperature hasn't changed, so for instance at 0, water will turn from solid water into liquid water. You add lots and lots of heat, but the temperature doesn't go up. Okay, it goes up from -3 to -2 to -1 to 0, and then you keep adding heat, and it's still 0 until all that ice is now melted into water. Now you have water at 0, and you continue heating it. It will rise until it gets to boiling. When it gets to 100 Celsius, you have to add a tremendous amount of heat, and it still stays at 100. It doesn't keep going up. You add more heat, it's still 100. Eventually, it has enough energy to turn all of that water into a gas. Now you have a 100-degree gas, but it's still 100 degrees. Now, if you add more energy, the gas temperature can go up. Okay, so we're going to look at solids, liquids, and gases today. So first of all, melting. So if you add enough energy to turn a solid into a liquid, you've melted that solid. And its opposite happens at the same temperature. If you remove enough energy to take away the energy of making it a liquid, then you make it a solid. Okay, so it's energy added to turn it from solid to a liquid, or energy removed to turn it from a liquid to a solid. Both of those happen at the same temperature. So it's not that liquids are hotter than ice. You can have water that's exactly freezing temperature, but it's not frozen. Okay, so you've removed or you've added the amount of energy it takes to turn it from ice to water, but you haven't added any more energy that would make the temperature now rise from 0 to 1 or 2, whatever. We call the energy added at melting the heat of fusion. Okay, the energy at melting is the heat of fusion, and it is exactly 334 joules per gram of liquid water. Okay, so to melt 334 joules of ice into 1 gram of ice into 1 gram of water, without changing the temperature at all, you have to add 334 joules per gram of energy in order to give it the energy, the random energy to move past each other out of that matrix. In the case of calories, if you want to do it in calories, it's 80 calories per gram. So how many kilojoules are released when 25 grams of water freezes at 0 Celsius? All right, so we're going to start with what we have. So we have that we have 25 grams of, water. Okay, 25 grams of water. We know that for every 1 gram of water, we need 334 joules of energy. Okay, now we're asked for how many kilojoules, so we say a kilo is 1,000. So in 1 kilojoule, there's 1,000 joules. So your math is 25 times 334 divided by 1,000, which gives you 8.35. All right, the next one is not going from solid to a liquid, but solid directly to a gas. All right, so for instance, if if you have enough energy to melt it, but if I give you the enough energy right now to not just melt it, but also boil it, remember it takes 334 joules just to melt 1 gram of water. Well, it takes 2260 joules to boil that gram of water from liquid to gas. Well, what if I give you enough to pay both bills all at once? Okay, you have so much energy that the water, the frozen water, goes straight to gaseous water. It doesn't even go to liquid. You just give it all the energy it needs. Okay, this is called sublimation. It sublimes when it goes straight into a gas. And the one you've seen is when we ever played with dry ice. Dry ice is carbon dioxide gas, which has been super cooled. Okay, so room temperature in Celsius is about 25 degrees, 24, something like that. So 25 degrees is normal room temperature. Well, the 78 degrees below zero will go straight in. That's enough energy to melt and boil. Okay. Well, if you take some dry ice and put it in room temperature, you've given it so much energy that it can go straight into a gas. And so it fogs. You can see it smokes. That smoking is called sublimation. Okay. Whenever water vaporizes to go to a gas, okay, you can call it evaporates because E means exit, vapor turns into vapor. Evaporates is turning water into a vapor, into a gas. Or you can say vaporizes. Okay, either one, it's the same meaning. So water vaporizes when you add sufficient energy to turn it from a liquid at that temperature at 100 to a gas at that same temperature. If you remove that, just like when you removed heat, it turned the liquid back into a solid. If you remove the heat at 100 degrees gas, they remove the energy, it condenses back into liquid. So water vaporizes or evaporates or boils, you think of it as boiling, as it goes to a gas, and it condenses at the same temperature as it goes from a gas back to a liquid. So boiling is when every molecule in the liquid acquires this in amount of energy to turn into a gas. That's why you see the bubbles, because all of that water is not air. It's not air bubbles you're seeing. It's not oxygen you're seeing. It's no gas you're seeing. It's vapor. It's water vapor. All of them from the inside and the outside, all at the same time, have enough energy to turn into a gas. And so all those gas, it's turning into a gas under the water, and so the gas is lighter than the water and it rises. That's why a rapid boil looks like bubbles. It's bubbling. Okay, so the bubbles appear not just on the top or not just on the bottom, but they appear everywhere in the middle and on the edges all at the same time, because boiling is when every one of those. So you can have maybe the top few molecules that have enough energy to evaporate. That's why you can take a glass of water and put it on the table, and in several days you've got much less water. Little by little at room temperature, that one escaped at a time, right? But if you boil it, every one of those molecules have sufficient energy to turn into gas at the same time. Okay, so the heat of vaporization is 2260 per gram of water. That's how much energy it takes to boil water. So here are some boiling and melting temperatures of some various things. You can see that, for instance, alcohol is 78 and boiling at 100. All right. Well, so ethanol melts at negative 114 but doesn't melt until 0. Do you see that water has hydrogen bonding, and that hydrogen bonding makes it sticky, and so it wants to stay together. It doesn't want to leave the jar. It doesn't want to go into the air. It wants to stay with its other sticky friends. So the more attractive forces between molecules, intermolecular forces, the higher the melting point, higher the boiling point would be. How many kilojoules are released when 50 grams of steam from a volcano condenses? All right, so you've got 50 grams of steam, and 50 grams of steam has a certain amount of heat in it. Okay, for every gram, there's a certain amount of heat required to turn gas or liquid into gas. So what shall we do? We're going to, first of all, for every gram, we know that it takes 2260 joules in order to turn from liquid to solid, gas. Also, removing 2260 joules to turn gas into liquid. So it's the same cost. Either you're paying it and making it go to a gas, or you're getting it back. It cools that much, and then it goes into a water. So for instance, the steam in the bathroom when you're taking a shower hits the mirror. The cold mirror absorbs the energy that gas has and turns it back into water. That's why you have water droplets on your mirror or on the glass in the shower door. That's the same reason. Okay, so 2260 per gram, and you're asked to find kilojoules again. So that's 1,000 joules per kilojoule. And so 50 times 2260 divided by 1,000 gives you 113. So here's a review. When gas goes straight to solid, it's called deposition. Oh, I never told you that. It's depositing, like frost in the freezer. If you've ever had a freezer that frosted over, that gas turns directly into a solid. If you've ever had ice cubes in the tray shrink, what's happening is that ice is going straight into the gas in the air, okay? And it's not turning into water first. It's going straight from ice into the air. When water turns into a gas, it vaporizes. When gas turns into water or a liquid, it condenses. And when liquid turns into a solid, it freezes. And when a solid turns into a liquid, it melts. So as it's going right in this picture, okay, you're absorbing heat. But when you're going left, you're releasing heat. Just like the hot gas water vapor in the air in the bathroom cools on the mirror absorbs that heat, and that mirror is warmer than it used to be, but the water is no longer gas, it's now liquid. All right, good job.